Good morning all together. This is Urs Simler speaking. I'd like to welcome you to the webinar about topology optimization, about a tool called ProTOp from a company CAESS, and we'd like to have a look at the news of the version 5.0. I set up a little agenda. So first the presenters will be introduced, and then a few words about the companies I'm working for, about GIA Informatik AG, and then the most important things, we're going to have an overview about the news in ProTOp 5.0. The news will be brand new interface, and of course we changed a little bit about the internal data structures. We have some new material laws. We can do mesh refinement in ProTOp, and we can speed up the process with the new combination capabilities, and also we'll see a speed up in the all over solving process, and then we'll have a overview about the optimization options, and I think very important about the OBJ export and the new smoothing capabilities in ProTOp. Yes, and of course this will not be all of the presentation will not be PowerPoint, and most of them we will do live presentation. And I prepared 2 examples to show you this brand new version of ProTOp. And at the end we're going to have a little Q&A session, so if you have any questions, please wait until the end of the webinar or send me an email or call me. Who is speaking? My name is Urs Simler, so it's easy to remember me. I have a special name, Urs. That means I'm a guy from Switzerland, and Simler means I'm doing quite a lot of simulation work, let's say, in the environment of PTC products. And here are my contact information, email and mobile. Unfortunately, Mr. Losley couldn't join the call. He's the account manager, so if you have further on any question about prices and so on, please contact him or contact me. That's no problem at all. Let's have a quick view at the GIA Informatik AG. GIA Informatik AG is located in the middle of Switzerland. So if you know a little bit Switzerland, here we have Zurich. Then we have our capital around here, that's Bern, and another bigger town is Basel, so in the heart of Switzerland. And we were founded in 88, last century. We have about right now 150 employees, and we belong to another company. It's called Müller-Martini. They have about 2005 employees, and they're working in the after printing process. They're producing machines for these processes after printing books. So they are producing cutting machines and handling machines, that kind of stuff. GIA has, let's say, 3 specialties. So we are working with SAP solution. We are doing IT services, and I'm working for the CAD/CAM, let's say, for the PLM part. We are doing consulting, implementation, support and service, so we don't only want to sell the software, we want to have in the end a successful customer, and we are working with partners in the PLM environment. Our main partners are those companies here. And the offerings of this, let's say, CAX groups are sales, training and consulting with the PTC Creo Parametric solutions, and of course in PTC we also have a second CAD system called Creo Elements Direct. We are also handling PTC Windchill and PTC MetCAD, ThingWorks and Navigate. And one partner of us is the Slovenian company CAESS, and from that company we do distribute ProTOp, and this webinar is about this tool. We have other tools for CFD simulation from Mentor Graphics. We are working close with TechSoft and with other company called Software Factory. Beside that, we are monitoring PDM systems from customers. We have a PDM ERP interface, and of course you can visit our training center in Oftringen to get trained on, let's say, all of those products. And in the end, our team has about 130 man-year experience in CAX PLM environment. But right now let's talk about the news in ProTOp. ProTOp, as I told before, is coming from this Slovenian company. The Slovenian company CAESS is a partner of PTC, and they provide a topology solution for about 2.5 years, which can be nicely connected to PTC Creo Parametric or to other CAD tools. So they brought in a new interface. I think it's easy, much easier to handle. It's easier to learn, so the learning curve is quite nice, and I think now this interface is much more flexible than before. Beside that, the developers, they changed the internal data structures. They want to be prepared for, let's say, future projects. They have quite a lot of ideas with what they can bring into topology optimization in the future, and therefore they restructured this data handling. And therefore, because of this restructuring, we're also getting, or we can see a nice improvement of the efficiency. Beside that, in ProTOp, we'll have a look at that later on. We brought in a new material law, so right now we can deal with orthotropic material behavior. A very, very important thing for me is that in the new version of ProTOp, which comes out next month, we will have, let's say, an internal capability to do the mesh refinement. Until now, we had to go, let's say, back for our simulation solution. In my case, it's PTC Creo Simulate in maybe CATIA or in Siemens NX. There you had to go back to this simulation solution to do the mesh refinement and to import the new mesh again and start with that new capabilities. Now we can do the loop of mesh, let's say, refinements. We can do that within the ProTOp version. That means we are much quicker, and it's not, let's say, that confusing, and it's really nice solution. You also get the estimation how much RAM do you use for solving, let's say, the equations with that refined mesh. So this is really my favorite news in ProTOp 5.0. Next thing is that the developers, they changed, let's say, the behavior, how they combine the load and constraint set especially when we are dealing with contact and plasticity. We will see a really nice speed up of the optimization process. In general, I would say ProTOp is about, let's say, 30%. ProTOp 5.0 is about 30% quicker than the old version 5.6, and we'll see that we do not need that much RAM anymore, and also we'll see a better performance. And I also like this window where you can see, okay, what will be the performance or the capabilities of your machine in the actual situation, how many nodes or how many elements you can solve in the actual simulation. Okay, there are also, let's say, new optimization option. If you, let's say, constrain here a component in that region, and then you, let's say, load your component in that region, now you can decide with that options, do I want to keep here, let's say, both regions like that one, so it's not allowed for the optimizer to take away material in that region, or in that situation here I said, okay, it's possible, let's say, to take away here just that displacement region. In the next one it's possible to take away, let's say, the load region, and the next combination of this checkbox here means, okay, both regions can be taken away. So you get much more flexibility in optimizing your boundary or loaded regions. Okay, we'll see later on that the smoothing of the surface is not now much easier. So you're getting here these sliders here, and with the help of the slider it's really very easy to smooth the surfaces, maybe in order to write out a STL file and use that STL file directly in your 3D printing process. So we can remove peaks, refine triangles, smoothing surfaces, and simplifying those surfaces. The next very important thing, let's say this is for me number 2 of the news, we have now a very nice capability to write out OBJ files. OBJ files are files which are used by this application called Wavefront, and many CAD systems like CATIA, Creo, Parametric, NX, they have capability to load these OBJ files, and that means at the end we are getting here like very coarse STL files. STL file, but this triangle will be, let's say, the skeletons for the surfaces, and the skeletons or this OBJ file can be read in right now in PTC Creo Parametric 4.0. It's a free capability which can be found in the Freestyle tool, and here you easily can import this data and you get a nice surface, and you can use that for validation or for let's say recreating your part. And of course some regions you will bring in some additional geometry to have there, let's say, some parametric geometry in the most cases that are the areas where you load or where you constrain your optimized part. Okay, this about the news. I mean, when you have read in that nice freeform surface, then you can do a validation in your FEM tool, but that's not a news, that's just an additional capability you get with this OBJ export. And beside that, you will see there are a lot of, let's say, little changes, but you will see that right now in the live presentation. Live presentation will be about, let's say, first a simple component. Maybe you saw in older demonstrations I did this wheel, but I think it will show quite nice how we can use these new options. I will show the new interface and also the surface smoothing capabilities and exporting this OBJ file. We will import the OBJ file in Creo Parametric Freestyle again and then do validation calculation in the FEM tool Creo Simulate. Of course, as I told before, there are customers which are using CATIA simulation, SolidWorks simulation, Siemens NX simulation. This can also be connected to that tools. Let's go for Creo Parametric. In Creo Parametric I created here, yes, let's say a cylinder with a hole, and at the end I want to create an optimized wheel out of that, depending on my loading and depending on my constraining. So I changed right now to the Creo Simulate mode, and in Creo Simulate I'm using the FEM mode. That means I will be able to create normal, or I will be create a mesh, an H mesh. And the H mesh will be created with, let's say, different material. That means with this material here on the line fix, I just define here that region, the outer region and the inner region not to be optimized. And let's say that in between here, the green material will be called AL2014. That means later on for the optimizer it's allowed to take away material in that region. For that I did some, let's say, volume regions, and I set it up a constraint in the middle, and I set up some loads on the highlighted region. I defined here a mesh control. The mesh control is, let's say, moderate. It's quite coarse. I set up 10 millimeters mesh control. The size of that wheel is about 250 millimeters in diameter. And then there is a analysis. Okay, and with this button up here, I can connect ProTOp. Now the 5.0 version will be connected with Creo Parametric, and we soon will see the new interface where we are going to import here our data. Okay, this is the new interface. I think it's quite easy to handle. Here we can display some pans, we can do, let's say, some cross sections. We can easily go to a front view, then do a cross section, and we can, let's say, go to our part with the cross section, and we have here, let's say, an initial view. Up here we can take out the graphic window, the commands window, and the project window. And in addition to that, there is a new logger for debugging reasons. Okay, in that case I quick go in and I just start the optimizer. So if you don't want to set up anything like constraining and that kind of stuff, you just can, let's say, push the button and say, okay, I want to optimize here my part. And I'm starting the optimization by defining my target here. The target should be taking out 50% of the weight. And in that case here I just want to see the stresses. Okay, and we see here when I'm looking from front, this part cannot be casted. I easily can see that when I'm going to have a look at the cross-section and when I'm going through my model here. The topology optimization is still on the way. We can see, okay, the target is nearly reached. Down here we have right now 50%, and if our target is reached, the optimization will stop, but I can stop it here also manually by hand. Good, so this is not the part I'd like to have because it cannot be casted, therefore I will, let's say, delete this optimized shape, and I'm going to set up here my model. So in that region, or on the Home tab, I mean, you just can import the new source and save your projects, and in the FEA model you'll see that later on. You see, okay, which component has which material, so it's much easier to see, okay, this is my fixed region in gray, and this is my optimized region in blue, and we see what kind of material is assigned to that region here. Here we have no imported surfaces right now. We can, let's say, convert our elements. We don't need that right now, and that we'll use later on, this mesh refinement, and here we see our load cases. Okay, let's go here for the optimization model. So I will set up right now my part. In order to get the casted part, I'm going to set up some new technology constraint. I'm adding a new one, and here I can say what kind of type do I want to use. So it should be B unidirectional open, and here I can define which volume region I'd like to have, not the outer one, the inner one, and it should be connected with that coordinate system, which axis here, the Z axis, and you see, okay, the casted part will be opened here from that side. Okay, and we can define here a draft angle, and we have a new technology constraint. We are adding a new one by copying the old one, and we are redefining the new one. We want to have a periodic constraint, and we want to have here right now every 45 degree. We want to have the same topology. And with that technological constraints, we're going back for our optimization process. Here in the optimization options, we can define here, should we take away the loaded or constrained regions, or what would it like to do. Okay, in the optimization process, I'm going in again. In that case, I'm starting the options, and now I'm changing my target here. I want to go down to about 32%. The target could be also, let's say, the maximum displacement or the maximum boundary stress. And now when I'm looking here from front, you see, okay, this wheel can be casted because there is draft angle on it, and it will be opened from the, let's say, middle datum plane. Let's have a look here at the cross section. Okay, component looks like that. And right now I'm a little bit in a hurry, so I'm taking out the material a little bit more aggressive, and you see, okay, this wheel looks more and more like a nice wheel, but here, let's say in that region, my meshing gets quite coarse, and so there is danger that you don't do, let's say, proper optimization. In that case, you should have, let's say, a nicer mesh. Therefore, I'm just pausing my optimization. I'm ending my optimization. Let's say the optimized shape will be kept by ProTOp. And now I'm going to that new options where I can do a mesh refinement. So in the old version, you had to go back to the, let's say, FEM system, to my Creo Simulate or to Simulia or something like that, to do the meshing again, exporting the mesh and bringing the mesh back to ProTOp. In that case, you're just going in and we say, okay, we want to refine that mesh on both regions here, and we just can go in and see, okay, we want to have, let's say, that number of modes, and we can define, let's say, a minimal edge length, and in that region or here, ProTOp is telling me, okay, for that mesh you need about 2.5 gig of RAM to solve it. And now we can do the mesh refinement. We'll see, okay, the mesh gets much nicer, and that means our topology optimization will be much more precise. And I will go back for this optimization, and I will not start it from beginning. I will start it, let's say, from the last version, and here I can restart my session from this shape here with 33%, and I'm setting up here a new target. In the end, I want to have a final volume of about 22%. And now the optimization starts over. So we took the old shape, but now with, let's say, the mesh refinement. So we're getting good stressed results in all that corners, and if ProTOp is opening a hole, you also can be sure that you have a nice stress distribution in that hole because of the mesh refinement. Here we can have a look at our volume target, and we are close right now to 33%. Of course, the solving takes a little bit more time because of much more elements in it. But it's running through, and you really can have a look at the topology during optimization process. You can bring in here cross sections, going through that cross section to get a better feeling about the behavior of your component, and during you're doing, let's say, post-processing, ProTOp is optimizing more and more, and right now we see, okay, we took out another, let's say, 5 or 10%. I'm taking out the cross section again, and I'm not that patient, so I'm stopping my optimization soon. Here in that region we see, okay, there is a hole is opening. Okay. There is sound in the background. Please could you mute your microphone or your phone? Thank you. And now I'm satisfied, let's say, with my shape here of that new rim, and I'm stopping my optimization. I reached here 25%. If I had more time, I would run it a little bit longer, but right now I want to pause the cycle. I want to end this session. It's doing the last cycle again. Okay, I'm ending the session. The shape will be automatically stored by ProTOp. And now I'd like to go into the export options of ProTOp 5.0, and here we'll see also some nice new capabilities. So first I'm going for smoothing my surface. In the new version we have here these 4 sliders, and we can select the surface and then by just moving those sliders we can take out here the peaks. Peaks will be nicely shown. I can refine a little bit my triangles. I can smoothing my surface, and then I can simplifying my surfaces here with that tool. And if I'm satisfied, I'm going for exporting, let's say, the surfaces. Until now it was more or less only possible to export, let's say, tessellated topology with, in the most cases, we took STL file. I'm doing that again. I will write out in my working directory STL file called AAA. This might be a good solution for 3D printing, but with that, let's say, STL file, it's not very convenient to do, let's say, a validation calculation or doing other stuff in your CAD system, let's say in Creo Parametric. Therefore, I'm using here the new capability called simplifying, and I'm going to simplify my model in very, very coarse triangles. These triangles here will be used later on, or right now will be used for exporting a OBJ file. So I'm going here for the new capability in 5.0, exporting an OBJ file, maybe also called AAA. Okay, and this can be read into the CAD system, can be read into Creo Parametric. Let's have a look at that new capability, or at that capability. It's there, I mean, in every version you can, let's say, open an STL file. This is not new in Creo Parametric. So I go for my AAA STL file, and let's say the tessellated geometry will be opened, and I can send maybe that one for 3D printing, or I can use it for other reasons. Next thing is the new capability in Creo Parametric 4.0. You're able to, let's say, read in the OBJ file. So I'm creating a new component. This is an empty component. And every user, every license includes the capabilities of Creo Freestyle. And in 4.0, you're getting here this new capability in Creo Parametric 4.0. This capability is also available in other CAD systems to open OBJ file. In Parametric, we're just importing that mesh, and we see that AAA OBJ file we exported 2 minutes ago. I'm importing that new shape, and I would say it's like a skeleton for a skeleton geometry for surfaces. And then at the end of the day, I can take my skeleton. It's importing right now, and I can drag these points right now here. This is the geometry which was optimized 5 minutes ago by ProTOp. And of course here I can save that surface. I can make a volume out of it. I can add some new features. Maybe in that case I would add here in the middle some geometry. I would add here maybe out around some analytical geometry in order to have, let's say, a nice part like that one here, with a nice surface outside, with a nice surface inside, and I can easily go with that one for my simulation solution. I can set up here maybe a constraint. In that case, I was setting up a eigenvalue calculation, and I was analyzing that one. Let's go maybe here for that status, and we'll see, okay, it took about 4 minutes with that number of elements to solve it, and I'm going to have a look at the results. Let's have here maybe a look at the results of the deformations. I'm going to animate here a little bit. and we'll see the eigenvalue of that optimized shape. Okay, I forgot here to bring in any deformation, sorry for that one. Okay, I'm doing it again, and of course you can see some stresses, all that kind of stuff can be seen in the validation calculation. Okay, this is now the behavior of the optimized shape. Let's go back for Creo Parametric again, and let's have a look at a much more complicated situation. Next part should be a bracket. This bracket, there was a challenge about this bracket. You can see that challenge on GrabCAD. It was about topology optimization, and here we also took that component for, or we will take that for live topology optimization, and at the end of the day we want to bring back this optimized shape for Creo Parametric, and we're doing again a validation analysis in Creo Simulate. Okay, let's go here for the Creo Parametric. Okay, not that window, not that window. I'm going to open here. Oh, I'm still in the post processor. Come on. I have to close that one. Leaving Creo Simulate, closing that window, and now I should be able to open this little assembly. And in that assembly I deal here with several parts. So right now the highlighted part, that one, that are the fixed regions, and the blue one is the optimized design room. And in Creo Simulate here I set it up my constraint data, and I set it up here, let's say 4 load state. One is upwards, one is let's say to Z direction, and here we have another one with a moment on it. The same behavior, set it up some material. The blue region is the design room, and here the gray region is my fixed region. And of course we have here again a mesh control. In that case the mesh control on the design room is a little bit nicer than this one on the gray part. I'm running ProTOp. Data will be transferred to ProTOp, and we are importing the geometry, and I'm going quickly for optimizing my component. I'm starting the session, and I will get, let's say, around 30%. Okay, because I'm in a hurry. Oh, we have still 20 minutes, and we are already optimizing the second part because I'm a little bit in a hurry. I'm more aggressive by taking out material and doing some smoothing of my geometry. You'll see here it's really performing incredibly fast for topology optimization. Okay, nearly 50% have been taken out, and right now the number of equations are decreasing, so every step goes quicker and quicker, but the mesh gets too coarse. So in that region I would say the mesh is now let's say too coarse for very, very good results. So I say, okay, I reached around 33%. I'm stopping here cycles, and I'm going for my remeshing in the FEA model. So I'm doing here mesh refinement again, on that component. This mesh is 2 cores, and I'm on a deal maybe with about 170,000 nodes. The maximum edge length should be 0.3 millimeters, and I'm refining my mesh. So this is really done within seconds. In the old versions it took you about 5 minutes to bring in a new mesh. Right now you really can solve that internally in ProTOp. And right now I'm going back for my optimization process. I'm starting the session again from that shape here, and now the optimization is on the run, and my target should be, let's say, around, I want to go down to 11%. So we're going to have a look at the stresses here, von Mises stress. Okay, we can change here the scaling, and you see right now quite a lot of material will be taken out again, and maybe we have to wait another 5 minutes to reach our target of 11%. Let's go maybe for in the meanwhile, going for the homepage of CAESS. Here you can see, okay, the new version is coming out in November. Although I have to tell you, some customers are already working with the new version. You can use the old license server. The new version is running very stable. The only disadvantage right now, there is no help right now in the version, but if you need the new version, you can get that one right now. And here you see some more details about the news. You have some screenshots to get used to the new capabilities of ProTOp 5.0. Right now we are, let's say, quite close to our target. We are right now on about 13.4%, and we'll see right now, okay, all of these small bars, they will disappear. If I don't want to use them, let's disappear, let's take them out. And now I say, okay, some of these bars I still like to keep, so I'm going to increase the number for or the volume again, and we'll see, okay, the bars here or the topology will get fat again because I raised this target here of my volume. Okay, and I would say this topology here looks quite interesting now. I want to keep that topology. Therefore, I'm pausing here or ending here my session. Okay, and I will do transfer to Creo Parametric again by exporting here those surfaces. I'm creating here some surfaces. I'm going to smooth it a little bit again. Okay, with the sliders. Okay, removing some peaks, removing a little bit more, redefining a little bit, smoothing the surface. This takes a little bit longer. And then doing a little simplification of the surface. And as before, we are going to export the surfaces, and let's do maybe first an STL export. Let's go for my home directory. Let's export an STL file called BBBB, and let's do right now a simplification of this STL file in order to get the Wavefront file, OBJ file. Okay. If you don't like it here, you could do undo, and you have the other one. But let's simplify it a little bit, and let's export it again for OBJ. So I'm going for OBJ, in my home directory. Yeah, that's okay. And it's called BBBB. Okay. And as before, we are going back for Creo Parametric. And in Creo Parametric here, let's do the first thing, opening the STL file. This is the, let's say, old way we brought in the STL. Okay. Oh, unfortunately, I mismatched the extensions. I don't want to import that one as an STL. So let's open again. This one should be really the STL. Okay. Okay, this is the new shape. You might use that for 3D printing, and I have to go back here for ProTOp to export this one, maybe with a more meaningful name. Let's do QQQQQQQ as an OBJ file. Okay, and now in Creo Parametric, I'm creating a new component. I'm going for my Freestyle option, and here in the Freestyle option I'm going to import that saved QQQQ. And this Freestyle files, or this shape you get in Freestyle, it's very flexible. You can drag it. I try to do that right now if it's visible here. So if you do not like maybe that shape here, you just go maybe for that edge, and then you can start to drag that edge, and you're getting, let's say, a new topology. And of course, we will use that topology for validation calculation or for other reasons to rebuild that part. If you really need maybe a casted part, then you have to, I would say you have to create a new one, but it's a very nice help if you have this Freestyle capability in Creo Parametric 4.0. We can see that here on that component. So I brought in, let's say, this OBJ file here. This is the OBJ file. I made a solidify, and before there I brought in, let's say, the geometry I'd like to use for constraining and for loading, and then I can go for my simulation again to do the validation calculation with the nice surfaces. I'm back right now in Creo Simulate. Right now I set it up here in analysis. Oh, this has the wrong name. So I can go here for the results. This analysis took about 6 minutes, and I'm going to have a look here at the results. Okay, it's right now here. On the right side we see our stress distributions on the left side, and on the right side we see our displacement distribution. Okay, that brings me, let's say, to the end of the live demonstrations. Just keep in mind with ProTOp, also with the new ProTOp, you can also perform nonlinear topology optimization, maybe with the help of contact and plasticity. So here we have a contact under these pre-stress screws. You can use, let's say, some configuration tools where you can say, okay, I want to deal with shells, or very popular right now when you have a 3D printer inside your topology, you can deal right now with optimized lattices. I mean, in Creo Parametric you can bring in lattices, but there you can never ever optimize them. But in ProTOp you are able to deal with optimized lattice structures. Okay, that's all about this webinar. So we still have, let's say, 5 minutes for Q&A session. So I try to unmute all of you, and yeah, if you have any question here, try to set up your, or try to answer some question. One moment, unmute. One moment, now all of you should be unmuted. Are there any questions out in the field? I hear somebody, but I can't hear you very well, so I would suggest if you have any questions, please send me an email. Here is my email address, so I like to answer your question over email, so I think it's not possible to do it here in the live session because the audio quality is quite bad. So please send me an email if you have any questions, and I really appreciate it, maybe to give you additional information about this tool. Wait here, Martin Devet was raising his hand. Martin, can you hear me? I can see him. No question about it. So yeah, now I can hear him. But I cannot understand you. Sorry, the audio quality is very bad. So I think please send me the questions with an email, and I will answer it as soon as possible, maybe this afternoon. So I really like to thank you for attending this webinar. I hope it was interesting for you, and yes, thanks again, and see you soon. Bye bye.